Hi guys, Assalamualaikum and good day. In this video, we're going to talk about the last part. Actually, not the last part, it's the second last part. We already skipped it before. It is about eigenvalue and eigenvector. Right? So, why did I put this as the last part in matrix? Because actually, to discuss on eigenvector and eigenvalue, you need to have a basic grasp on what is vector, right? Because the name is eigenvector. So if you have no idea what is vector, then it might be a little bit difficult for us to go to proceed with these topics. So in this video, what I'm going to do is just to give you a brief introduction of one properties of vector that is actually related to eigenvector and eigenvalue. So after that, in the next video, we're going to discuss on how to do that. Okay, how to do eigenvector and eigenvalue. Alright, so vector, right? When we say vector, this is actually the topic that we're going to cover in the next chapter. However, let's just talk about it just to get an introduction a little bit. Vector, when you talk about vector, when you have a value of vector, right? When you see a value, then you are being told that that is a vector. It means that that value holds two things. Okay, so the first thing, that value indicate a magnitude, and the other one, it also indicate a direction. So those are the two things that characterize vector. So if you don't have one of these character, it is not a vector. So basically, when you have an information that contain both magnitude and direction, it can be classified as vector, right? So for example, if I say that I want to move this box, this is a simple example. I want to move this box. No, I want to move this box 5 meters away from me. So based on that information alone, we know the magnitude, which is 5 meters away, 5 meters, but we don't have the information of direction. So 5 meters to which direction? So basically, that is not an information of vector. So for it to be a vector, I need to be specific. I want to move this box 5 meters to the left. So that is a vector. Alright? So that is just a simple information example of what is a vector. So vector is a number, right? So now let's try to look at this graph. Let us try to demonstrate in a simple way what is vector. So if, right, let's say I just input 1 1 like this, coordinate 1 1, this is not a vector because this is just a location, just a coordinate in a Cartesian coordinate, right? So if I say that I want you to show me vector 1 1, so if you just put it like this, it is wrong, right? It is wrong because it is not a vector. Remember, a vector should have magnitude, which is size, and also direction. So if I say that I want you to show me a vector of 1 1, which is, we have 1 1, the same as you read a coordinate, vector 1 1, but not the location. I want a vector from origin, meaning from the origin 0 0. So if I want you to show me a vector, instead of showing me this dot here, you will need to show me this, right? This kind of arrow, right? From origin to point 1 1. This is a vector. Okay, so I hope that you're clear what is a vector, what a vector is. But it has a magnitude and also a direction. Right? We know that this is now the direction is this way. Okay, for this one. So now let's talk about one property that we're going to use later in eigenvector and eigenvalue. Okay, so one properties of one of the property of vector is that when you multiply any value, any constant to this vector, what will happen is that it will either expand the vector, the magnitude of the vector, maybe it will become longer, or it can become shorter, and it can also go to the other way around, as long as it is on the same line, same gradient. So that is if what will happen if you multiply a single value to that vector. So it will change the magnitude and the direction, but not the tiltness, not the arguments, the degree, right? So let's try to demonstrate a bit. What happens if I multiply this vector with one value, let's say 5? So if I multiply 1 and 1 here with 5, it will become 5 and 5. So basically this is what will happen. It will expand, right? Now instead of just until 1 1, now it expand to 5 5 within the same line. See, because I just multiply it with one value. Right, now let's try to multiply with a different value. Instead of multiplying by 5, now I try to multiply with a negative value, let's say negative 3. So now instead of 1 1, it become negative 3 negative 3. So see what happened to the line. Now it did expand, but to the other way around, but still on the same line. Okay, so let's try to multiply it with one more value. Let's say, let's go small this time. Let's try to multiply it with, instead of just this is 1, let's try to multiply it with 0.5. 0.5 times with this vector. So we can get 0.5, 0.5, right? So what happened to the line? Now if I just see, it actually, the magnitude or the length is actually decreasing. Okay, so that is one of the property that we're going to use later. Whatever constant being multiplied to this vector will either expand or reduce its size, or even go the other way around, but still on the same line. That is the idea we are going to use, that we are going to use later in finding eigenvector and eigenvalue, right? So if we try to write it down, right, let's say let's go back to vector 1 1. Okay, if I try to write it down, that is one way to write vector in the form of matrix, which is this one, right? This way. So if it is just 2 dimension, it will be written down in a 2 times 1 matrix, right? 2 times 1 matrix, 1 1. If it is later in a 3 dimension, where you are going to have 3 values, x, y, and z, basically you're also going to have 3 value here. So the metric form will become 3 times 1. So this is a metric form for vector. Now, just now I did mention that when you multiply any constant, they were going to give you, it will going to affect just the magnitude, the length, right? And also the direction. It can go the other way around, but not the tiltness, right? So just now, if I multiply it to 5, right? 5, what will happen is that it is expanding. So in term, if you want to write it down, it is actually, we can put it 5 times with the vector that will give us 5 5, right? 5 5. So this is a new value after you multiply it, but still, if you try to look at it graphically, it is actually on the same line. The same if you try to multiply with, just now we have -3 and we also have 0.5. This value change, but it will still remain at the same line, right? So that is the idea of one of the properties in vector that we are going to cover in chapter 3. Right? But we are talking about it now because we are going to use it later in eigenvalue and eigenvector. Alright, so let's talk about eigenvalue and eigenvector in our next video. Alright, thank you.